Hi, this is a presentation outlining our report and design process for our project. Our goal for the project was to research and design an economical pump for use in developing areas. To achieve this, our pump had to be cost efficient and simple in design such that the pump is easy to construct and repair. Our team for this project is as follows. Our product is a modification of the India Mark III pump. It is a piston pump which is capable of extracting water from up to 25 meters. In the next section, we will discuss some design prototypes. Our first design is Michael's India Mark III. This pump was attractive because of how easily modifiable it was, allowing a simpler design. It is also easy to maintain due to its open top cylinder, seen on the left, allowing easy extraction of the plunger and foot valve. The design also has a simple lever and piping system which other designs lacked, and can be adapted to a windmill or generator. The design, however, requires specific installation tools and due to open-top cylinder, has a limited depth of up to 25 meters and is heavier. It should be noted that the following designs are also open-top cylinder. Our second design is mine, and is a version of the Gibbon pump. This design is easily maintained due to less specific tools required and having less parts. However, has a limited depth of 18 meters and complex assemblies. The third design is Massimo's version of the Aphrodite pump. It has the advantages of needing only simple tools to assemble and very simple piping. However, requires many parts and many complex assemblies. Of all the designs shown, Michael's was the best. A scoring matrix aided in highlighting the features of the design. For example, its high modifiability reduces parts required, simplifying the design, but because the design requires specific tools, complexity increases. It should be noted that all the materials used in the designs shown are recyclable.
The India Mark III is a lever-action water pump designed for durability and maintainability. Its most notable features is the open-top cylinder and a lack of reducer. This design builds upon the selected design, primarily focusing on improving simplicity and maintainability. The three main mechanisms, the manual pumping action, the plunger, and the foot valve remain the same. For simplicity, the tripod used in the India design has been removed as it is only required for deep wells that are more than 10 meters. The first of many alterations is the opening of the pump head, giving access to the chain that connects the handle to the rod. Most India designs use a lid to cover the access point. However, we can simply cover the access point with a small top, reducing the number of individual pieces needed. The redrawer includes the flanges on all three subassemblies and the hexagonal nut and bolts required to keep the pump intact. The top assembly is comprised of three subassemblies. These are the standing pipe, the water tank, and the head assembly. The standing pipe supports the other two assemblies and will most likely be a single piece with the casing pipe that protects the rising main. The tank subassembly has a spout fitted to it, and inside is the rising pipe hold, which supports the riser pipe. The head assembly houses the pivot for the handle and the handle itself. The curved quadrant will serve as a guide for the chain. The riser pipe is 3 meters long with an outer diameter of 90 millimeters. The threading at both ends is 22 millimeters. This thread will allow for the riser pipe holder to be screwed on, securing the pipe to the water tank. Here we have the pump shaft rod with a total length of 3.02 meters. We have a 20 millimeter thread at the top and then hexagonal couplers at either end. So this is the final design made in SolidWorks. The total height is 3,499 millimeters, or 3.499 meters. All sizes except for the threads, nuts, and bolts are arbitrary and still up for change. And this model does not include the plunger and foot valve as of yet.
Manufacturing process of the final pump, designed for sustainability. By classifying what materials are sustainable early on, we can identify which components could be exchanged for alternative solutions that are more sustainable. An example of this is any plastic piping used in the Indian Mark III pump could be interchanged for clay or galvanized iron piping. However, this could implicate the pump into more maintenance being required and would increase the economic budget. Parts and material. The pump head, handle, water tank, pump stand, and pump rods will be made of galvanized steel. The rising main pump, made of galvanized iron. Pump cylinder, plunger, and foot valve will be made of brass. Rubber seating and cup seal made of rubber, and the O-rings are made out of natural rubber. In terms of manufacturing the core components of the Indian Mark III hand pump, it seems most efficient to use the process of sand casting metals, which utilizes sand as the mold material. However, for the brass pipes and tubes, they are formed by extruding or squeezing rectangular billets of hot brass through a die to form long hollow cylinders, All metal parts will be galvanized, which is achieved through the process of immersing the metal in molten zinc, whereby once completely covered, a reaction between the metal and zinc occurs to form a combination of zinc alloys. The manufacturing of all rubber parts will be done through two processes, one of which is calendering, which is the process of shaping it through rollers, and extrusion, whereby it is cut into shape. The production of null rubber for the O-rings will be done through an emulsion polymerization system, whereby monomers are introduced into a vessel, ultimately producing nitrile rubber.
We can decisively conclude that the criteria and the goal of the Hand Tools water pump project was met. This project was a good opportunity for the project collaboration and team skills, as well as teaching us how to apply the manufacturing engineering principles in the pump fabrication process. Our team was successfully able to design the pump as well as comprehend the attributes of it. Even though we did not create a physical model to demonstrate the water pump's functionality, we can in detail explain the design and the manufacturing processes evidently shown in this presentation. The research and planning in this presentation has given our team invaluable understanding of our water pump and will be a precursor to our final hand pump project report.